Hello, and welcome to Sleepy Scientist. I'm glad you're here, whether you've had a long day, a busy mind, or you simply love falling asleep to the sound of science. Tonight, we drift far above the Earth, riding silently in the shadow of an orbiting satellite, where the planet's surface becomes a living canvas. Through the lens, you see them pale blue-green halos scattered across vast ochre deserts. They look almost painted on, as though an artist had dipped a brush into turquoise water and traced gentle circles over the sand. But these aren't strokes of paint. They are real, tangible shapes, some the size of small cities, etched into the crust of our world. If you enjoy these sleepy explorations, I'd be so grateful if you gave the video a little like and tapped that subscribe button. It helps more sleepy scientists like you find their way here, and it means I can keep making more of these journeys for you now. As you gaze downward, the first thing you notice is how still they seem. No movement, no sound, just shimmering outlines soft against the sharp lines of dune crests. The light at this altitude has no haze, so the colors appear almost unreal, like the rings are glowing from within. They lie in places where you might expect nothing but emptiness, deep in the Namib across the Arabian sands or the plateaus of Australia. These blue-green shades aren't really blue or green in the way your eyes know them. They're the satellite's composite trickery, showing vegetation or mineral content invisible to your natural sight. Imagine the Earth whispering secrets through color codes, revealing what lies hidden to most of us who stand on her surface. You might ask yourself, why rings? Why not squares or random blotches? Nature, after all, doesn't have a drafting table, or does it? Here from the thin silence of orbit, it's hard not to imagine the land itself keeping a secret geometry, one that we only discover when we rise high enough. On the ground, these halos vanish into the noise of the landscape. You could stand in the very center of one and see nothing unusual, just sand, maybe a few hardy shrubs, perhaps a stone underfoot, still warm from the day's sun. But from space, the pattern leaps out, as if Earth had drawn an invisible fence around this spot. Scientists first spotted many of these strange shapes when satellite imagery became widely available in the mid-20th century. At first, they thought they might be the remains of ancient civilizations, collapsed city walls, or ceremonial circles. Later measurements revealed their immense size. Some rings span several kilometers, perfectly round their edges, as defined as the rim of a teacup. Think about the patience it takes to form such shapes. Some began millions of years ago, as minerals seeped upward through fractures in bedrock, staining the surface soil in a broad circle. Others are far younger, born from plant life, finding a way to thrive in harsh environments, clustering in a ring where moisture gathers most easily. Even now, their edges are alive, growing, shifting, dissolving, while their centers rest quietly, like the calm in the eye of a storm. From this height, every one of them tells a story, even if you can't yet read it. One ring may be a fossilized splash of an asteroid impact the Earth's skin still bearing the bruise. Another could be the mark of an ancient lake's shore, its waters long gone, but its memory traced into salt and soil. And some are so faint, you wonder if they are simply tricks of light, yet the satellite confirms them again and again. It's almost as if the planet is dotted with silent clocks, their circular faces turned upward, all ticking at different speeds. You begin to feel the pull of their stories, the urge to drift lower, to touch the sand, and find what secrets lie at the very center. But for now, we hover here in the quiet, letting the cool colors and perfect curves lull us deeper into the night's orbit. From our high perch in the shadow of the satellite, the blue-green halos fade behind us, replaced by a different kind of circle. This one buried so deep beneath the sand that it only emerges through patient study. You pass over an endless expanse of desert, but the satellite's sensors peel away, the layers revealing a ghostly outline hundreds of kilometers wide. This is no surface stain, no trick of vegetation. It is an ancient scar. The ground here carries the memory of an impact so old that time itself seems to have forgotten it. Millions of years ago, perhaps in the late Paleozoic or early Mesozoic, a rock from space came screaming through the atmosphere. Imagine it for a moment, a blazing sphere, the size of a house moving faster than a rifle bullet tearing through the sky. The air ahead of it compressed into a wave of searing heat. Then, in a fraction of a second, it struck. The earth shuddered. Rock behaved like water, rippling outward before freezing the mid-wave. The energy released was beyond human comprehension, more than the strongest nuclear weapon ever built. A crater formed deep and wide, its rim rising like a wall around the wound. In the first hours, molten rock filled the cavity, and vaporized minerals drifted high into the air, perhaps even changing the climate for years afterward. Now that violent moment is gone. The winds have buried the crater beneath dunes, the rains have softened its edges, and the desert sun has bleached it into pale anonymity. If you were to walk across it today, you would feel nothing but shifting sand under your boots. But from above, from above, it is unmistakable. The ring remains a perfect curve in the bedrock, patiently sleeping under its blanket of sand. You might wonder how many of these scars are out there invisible to our eyes, but silently holding the history of cosmic encounters. Scientists have identified nearly 200 confirmed impact craters on Earth, but estimates suggest there could be thousands more, hidden beneath forests, oceans, and deserts. Some are small, just a few meters across. Others, like the Chicxulub crater in Mexico, stretch more than 180 kilometers, so large you could fit a small country inside. The one below us now is nameless to most of the world, yet it has shaped the land for ages. Its buried rim guides the flow of underground water, forming circular oases that appear in satellite imagery, like emerald jewels in the tan desert. Animals follow the greenery, and their paths trace soft lines toward the ring's edge, as if drawn to it without knowing why. If the Earth were a person, this crater would be an old scar on her skin, one she wears without shame, because it speaks of survival. The planet has taken countless blows, and yet here she spins, still nurturing life. It's humbling to think of how brief our human history is against the backdrop of such events. This ring was here before the first dinosaurs walked, before the continents took their current shapes, before the stars above us were arranged as they are tonight. Beneath the sand, the rocks still bear signs of that long-ago shock. Quartz grains have been deformed into microscopic zigzags, a signature that only extreme pressure can leave. Melted fragments of the old surface lie frozen in place, as if still mid-splash. If you could pick one up, you might think it was just another stone, until you remembered it once flowed like molten glass. As the satellite glides onward, the sunlight shifts, and the ghost ring begins to fade into the background again, hidden in plain sight. Somewhere below, wind pushes across the desert floor, erasing footprints, scattering dust, and slowly, almost lovingly, softening the contours of the ancient rim. Time, it seems, is patient here. You might find yourself asking what other stories lie beneath our feet, invisible until we step far enough back to see the whole picture. The answer is out there in countless curves, etched into the Earth's crust, waiting for us to notice them. Waiting for us to remember that the ground itself is an archive of the cosmos. Drifting farther along our orbital path, The desert below gives way to rugged highlands, their surfaces folded and wrinkled like the skin of an old wise hand. And then you see them, not the ghost of an impact, not the pale memory of a vanished lake, but bold, solid rings, their edges defined by dark volcanic rock. These are circles born not from the sky, but from the deep, molten heart of the earth. From above, they look impossibly perfect, like someone pressed a cookie cutter into the planet's crust. Some are so vast, they would take hours to cross on foot. Others are smaller, only a few hundred meters wide, yet each one bears the same signature, a central dome or depression surrounded by a raised circular ridge. These are volcanic rings, silent monuments to eruptions that once roared like giants. Picture it molten magma surging upward from deep in the mantle, forcing its way toward the surface. Sometimes it explodes violently, hurling ash and rock into the sky, carving out a crater in the process. Other times, it bubbles up more gently, spilling lava that spreads outward before cooling. But here, in these rare cases, the eruption follows a fault or fracture shaped like a ring. As the magma chamber empties and collapses, the ground above sags in a perfect circle, leaving behind the unmistakable mark we see today. You might wonder, how does molten rock, unpredictable and wild, create something so precise? The answer lies in the quiet symmetry of geology. Stress patterns deep underground can naturally form circular weaknesses. When magma finds these, it follows them like water, following the edge of a bowl. Over thousands of years, erosion clears away the debris, revealing the graceful lines of the ring. The one we pass over now is old, so old that its once black basalt has weathered to a rusty brown. Shrubs cling to its slopes, and inside its boundaries, small farms have sprung up their green fields, forming a second smaller circle within the larger one. If the volcano is the architect of the outer wall, people have become the painters of its interior. The volcano itself is quiet now, but if the earth were a storyteller, she would still remember its voice. There were days when molten fountains lit the sky, when rivers of fire curled through the landscape like glowing snakes, when the air itself shimmered with heat. From space, you can almost imagine the heat radiating outward in concentric waves long before it cooled into stillness. And here's a thought to turn over gently in your mind. How many of these volcanic rings have shaped the way people settled and moved? From high above, it's easy to see how the circular walls could offer shelter from wind, how fertile volcanic soils might encourage crops, how the ring's inner basin could hold water after rain. In a way, these geological creations may have guided human history without us even realizing it. The volcanic rings are scattered all over the globe: Harat Hutaima in Saudi Arabia, the Valles Caldera in New Mexico, the Great Ngorongoro crater in Tanzania. Each has its own personality. Some are broad and open, inviting the sky into their hearts. Others are steep and hidden, keeping their secrets close. The one beneath us tonight lies far from any major road, a quiet circle in a lonely land, visited mostly by wind and the occasional bird tracing its own invisible arc above. As the satellite continues its glide, the shadows lengthen across the ridges, emphasizing the perfect geometry. It's almost hypnotic, like staring at the ripples from a stone dropped into a pond, frozen forever in stone. The temptation is to keep staring, to keep tracing the outline until your eyelids grow heavy. But the planet is still turning, and more rings await just beyond the horizon. The volcanic ridges fall away behind us, replaced by a flat, pale surface that gleams faintly under the sunlight. At first it looks like someone spilled flour across the land, a vast, powdery sheet stretching for kilometers. But then subtle curves appear, broad, milky white arcs that form near-perfect rings. These are salt rings, the lingering outlines of lakes that once mirrored the sky but have since dried to silence. From above, they look almost delicate, like the faint rings left on a tabletop after a glass of water has been lifted. Yet each one marks the edge of a body of water that once pulsed with life. Thousands of years ago, perhaps, after the last ice age, meltwater from glaciers or seasonal rains filled low-lying basins. Fish swam in their depths, birds wheeled overhead, and reeds swayed along the shore. But climates shift, winds change, and rivers wander. Slowly the inflow diminished, the lakes shrank, and eventually they disappeared altogether. What remains is the salt, the fine crystalline residue left behind as the last drops evaporated under the relentless sun. Over centuries, wind and rain rearrange it into pale halos that trace the shape of the vanished shoreline. These rings visible from space are the ghosts of ancient waters. You might find yourself wondering, if we could walk there now, what would we hear? Perhaps the crunch of salt crystals underfoot, the faint hiss of wind carrying the scent of minerals. In some places the salt glitters underfoot, like frost, even in the heat of summer. If you knelt and touched it, the crystals would cling to your fingertips like stubborn snowflakes. From a scientific eye, these salt rings tell more than just the story of a vanished lake. They speak of entire climate histories. By drilling deep into the salt layers, researchers can find pollen grains, chemical traces, even microscopic shells of plankton that lived and died in the lake's waters. These layers act like pages in a diary, each one recording a season, a drought, a flood. If Earth were a person, these salt rings would be her faded photographs, memories she keeps, even after the people in them have moved on. Each white arc is a shoreline that hasn't felt a wave in centuries, yet still curves patiently around the place it once embraced. In some corners of the world, like the Great Salt Lake in Utah or Lake Eyre in Australia, we can watch the process happen in real time. The shorelines expand and contract, with the seasons painting new rings over old ones, like an ever-changing canvas. From orbit, you can see these patterns shift from year to year, proof that the Earth's surface is never truly still. And here's a quiet, almost sleepy thought. Could there be lakes drying right now, drawing their first pale rings in places no one has noticed yet? Somewhere in a remote desert. Perhaps this very moment the waterline is receding, leaving behind a fragile white border that will one day be visible only from the silent view of space. Below us now, the salt ring gleams brighter as the sun catches it at an angle. From here it looks whole and unbroken, but on the ground it's fractured by gullies, cracked by heat, and patterned by the tiny footsteps of animals crossing the flat. The wind whispers over it, carrying flecks of salt into the air, letting them fall again a few steps away. This slow, constant rearranging is part of the ring's quiet life, a circle not frozen in time, but still breathing in the rhythm of the desert. We drift onward, leaving the bright halo behind, its pale memory still lingering in your eyes. Beyond the horizon, the land begins to soften with green, again hinting at another mystery waiting for us. As the pale gleam of the salt ring fades behind us, the land below begins to blush with soft green. It's not the dense green of rainforests or farmland, but a sparse, speckled pattern, patches of grass set against the tawny backdrop of dry soil. From this height, those patches form strange, deliberate shapes, near-perfect circles each a few meters, to tens of meters wide, scattered like coins tossed across the landscape. These are the fairy circles, one of Earth's most quietly puzzling patterns. They appear most famously in the Namib Desert, but you can find them in other parts of the world, two arid lands where life must work for every drop of water. In the Namib, each ring is a bare patch of reddish earth fringed with a halo of taller, healthier grass. To walk among them is to step between empty spaces rimmed with green, like standing inside giant bowls turned upside down. From space, the effect is mesmerizing, a polka-dotted desert, every circle so consistent in size and spacing that it looks like someone arranged them with purpose. But no human hand is responsible. Theories abound, and scientists have been chasing explanations for decades. Some believe the circles are the work of termites, industrious engineers, that clear vegetation in specific spots, creating reservoirs of water under the bare soil. Others suggest they arise from plants themselves, competing for water and spacing out in a perfect balance where each clump gets just enough to survive. And still others wonder if it's a combination termites and plants working in an unspoken alliance. You might ask yourself, could these circles be a form of communication between life forms in unspoken agreement on how to share scarce resources? It's tempting to think of the plants as neighbors, keeping a polite distance, respecting each other's invisible boundaries. From a scientific perspective, the circles are a marvel of self-organization. Similar patterns occur in chemical reactions, frost crystals even in the spots on a leopard's fur. It's nature's geometry order emerging from chaos without a single overseer. If Earth were a gardener, the fairy circles would be her delicate minimalist landscaping, each one a careful space left for air and light. In the dry heat of midday, the bare centers seem lifeless, but dig just a little, and you might find moisture clinging to the soil enough to keep the surrounding grasses taller and greener than the rest of the desert. Over the years, the circles shift slightly, new ones appearing, while others fade. From above, it's like watching a slow-motion dance, each step measured in decades. When rain does come, the transformation is quiet, but dramatic. The fringes flush with bright green, the circles become even more pronounced, and the desert floor feels momentarily alive with invisible choreography. Yet within months, the heat returns, and the bare centers reclaim their dominance. Flying over them now, you notice the subtle gradients, the largest circles scattered far apart, smaller ones tucked between them. It's a pattern so regular, it feels intentional, yet so ancient and slow-moving, it slips beyond human urgency. It's humbling to realize that while we search for answers, the circles go on forming and fading without caring whether they are understood. They are part of the desert's breathing its own quiet rhythm. Perhaps that's why they have such a lulling quality, especially from this height. They remind you that not every mystery needs solving before you can simply admire it. Below, the green fades again, the circles growing smaller and sparser until they vanish into the open desert. Ahead, another kind of ring waits, this one not grown from plants or carved by heat, but struck into being by visitors from the far reaches of space. The scattered green of the fairy circles dissolves into pale sand once more. But this time the rings that appear ahead are sharper, cleaner, as though drawn with a single unbroken stroke. From space they resemble ripples on a frozen pond, perfect arcs that surround a central point. These are the impact craters that remain visible to the naked eye, their shapes carved by cosmic visitors and preserved across unimaginable spans of time. The one we pass over now could almost be mistaken for a giant coin pressed into the surface of the earth. Its raised rim casts a thin shadow on the inner slope, and the basin within lies quiet, filled with sediment and in some cases small lakes. But this stillness hides an origin story as fierce as anything the planet has endured. Picture it thousands or even millions of years ago, a meteorite, a chunk of ancient rock or metal, perhaps older than Earth itself, hurtled toward the planet at tens of kilometers per second. In the moments before impact, it would have flared brighter than the sun, trailing a tail of fire and vapor. And then, in less than a heartbeat, it struck. The force was so great that rock behaved like a liquid, splashing outward, forming those concentric ripples that remain frozen to this day. You might ask yourself, how does a shape born of chaos end up so beautifully symmetrical? The answer lies in the physics of the explosion. The energy radiates evenly in all directions from the point of impact, like a stone dropped in water. In those first fractions of a second, the planet's crust responds not as solid land, but as something fluid, allowing the ring to form with astonishing precision. From here, it's easy to imagine the crater as a still eye staring silently at the sky that once sent its destroyer. Over time, rain and wind have softened its edges, filling the basin with soil. Plants have crept in, and animals have made their homes in the sheltered hollow. To a traveler on foot, it might look like a pleasant valley, but from above the symmetry gives it away. Some of these craters still bear secondary rings, raised terraces within the rim, formed as the ground collapsed in stages. Others have central peaks, jagged reminders of the moment the Earth's crust rebounded upward after the blow. The variety is as wide as the stories they tell. If the Earth were a person, these impact craters would be her deep-set eyes, windows through which you glimpse not just her history, but her resilience. She has taken hit after hit, yet here she turns carrying the marks with quiet dignity. The one below us now is about 40 kilometers across. Its walls rise 100 meters above the surrounding land, though erosion has been steadily wearing them down. Within the basin, you can see faint traces of old river channels, water that once flowed here, turning the scar into an oasis. Even now, if you were to stand in the center and look up, the surrounding rim would form a perfect horizon, a ring of land meeting the sky. As the satellite glides onward, the shadow in the rim shifts, and the crater's circle seems to pulse, faintly a trick of light and distance. You can almost imagine it breathing, not in the way a living creature does, but in the slow, geological rhythm of the planet. Inhale for centuries, exhale for millennia. Soon the circle slips behind us, but its story lingers. Somewhere out there in the darkness of space, more rocks wander the void as they always have. And one day, perhaps thousands of years from now, another ring will be born on this spinning blue world, joining the quiet collection we're tracing tonight. The memory of the impact crater fades behind us, and now our view dips toward a more delicate kind of circle, one not carved by brute force, but coaxed into being by life itself. At first, these rings seem like stains, faint swirls of rust and emerald on the ground. But as the satellite's instruments shift into other wavelengths, their colors sharpen, revealing a partnership between two quiet architects, microbes and minerals. From above, the rings can stretch for tens or even hundreds of meters. Their edges are crisp, yet inside the colors bloom and fade in soft gradients, ochre blending into jade sapphire, melting into chalky white. On the ground, these patterns might look like shallow mounds, crusty ridges, or even pools rimmed with strange colors. They are the result of chemistry, guided by life on the smallest scale. Imagine water trickling over mineral-rich ground, perhaps from a hot spring, perhaps from a slowly seeping underground source. Within that water, microscopic organisms make their living feeding on dissolved elements, or sunlight exhaling byproducts that change the chemistry around them. Over time, they create conditions where certain minerals precipitate out, clinging to the ground in a circle around the colony. Layer by layer, the ring grows. You might ask yourself, could such tiny beings be aware, in some strange microbial sense, of the beautiful geometry they leave behind? Probably not in the way we understand awareness, but in their quiet persistence, they are shaping landscapes visible from hundreds of kilometers above. Some of these formations are found in salt flats, where cyanobacteria thrive in thin films of brine, painting subtle rings in shades of pink, green, or gold. Others form in volcanic regions where mineral-rich steam rises through cracks in the earth, feeding unique microbial communities that leave colorful halos on the ground. The chemistry is like a slow conversation between life and rock. Iron, sulfur, calcium, silica. Each plays a part, sometimes staining the surface, sometimes building it up. If Earth were a painter, these rings would be her watercolors, each hue telling a story of temperature, salinity, and the stubborn will to survive. From a distance, they are peaceful. Up close, they are worlds in miniature, intricate cities where trillions of tiny inhabitants work without pause. Their shapes follow invisible gradients. Where nutrients are strongest, growth thrives. Where it thins, the community stops leaving the precise edge of a ring. Scientists sometimes call this a reaction diffusion pattern, the same kind of mathematics that shapes seashells and animal markings. One particularly striking ring below us now lies in a remote desert basin. The inner circle glows a pale turquoise from mineral deposits. The surrounding halo shifts to deep red where iron oxidizes in dry air. Beyond that, the colors fade into beige desert as though someone has softly erased the lines with a fingertip. No one lives nearby, no road passes close. Yet here it is, thriving quietly, indifferent to whether anyone notices. You might wonder how long would such a ring survive if left untouched. Some persist for decades, renewed by each season's rains. Others harden into stone-like crusts that could last centuries. And in that time, they might record subtle changes in climate or water chemistry, nature's way of keeping a journal in color. As the satellite drifts onward, these microbial masterpieces grow smaller in our view, like the closing frames of a slow, cosmic film. Ahead lies another kind of ring, one not made by nature alone, but shaped by human hands, aligning stone and earth with the stars themselves. The chemical halos fade behind us, their colors dissolving into the neutral tones of dry grasslands. Soon the surface below becomes patterned with lines, mounds, and shapes too regular to be nature's alone. Then, like coins laid upon the land, the next rings appear so precise and deliberate that you can almost sense the intention behind them. These are sacred rings built by human hands long ago, aligned not to water or geology, but to the paths of the stars. From above, their symmetry is unmistakable. Some are simple earthen embankments forming a perfect circle. Others are elaborate constructions of standing stones, radiating pathways, or concentric walls. At ground level, they might look weathered and broken, half swallowed by grass or soil. But from here, the design snaps back into focus, the geometry glowing against the natural curves of the land. Imagine the people who made them thousands of years ago, with no satellites, no aerial views, no metal tools. In some cases, yet able to measure and place each stone with astonishing accuracy. They worked with the slow patience of seasons, hauling stones from distant quarries, shaping them, setting them upright, aligning their arrangement with the rising sun at midsummer or the position of a bright star just before dawn. You might ask yourself, What would it feel like to stand in one of these circles on the exact day it was designed for and watch the first light or the last light fall perfectly through the gap in the stones? Would you feel the pull of those who stood there before watching the same alignment centuries earlier? Many such rings are scattered across the world. Stonehenge in England, the medicine wheels of North America, the great circular earthworks of Africa and South America. Some are clearly ceremonial, linked to solstices or equinoxes. Others remain mysterious, their original purpose lost to time. Yet all of them share one thing: the circle as a universal language. If Earth were a storyteller, these human-made rings would be her spoken words, where people shape the land to tell the sky's story back to itself. The stones became pages, the alignments became sentences, and the rituals became the reading of those sentences, aloud, generation after generation. From a scientific lens, these rings also hold clues about ancient life, how far people could travel, what resources they valued, even what they believed about their place in the cosmos. Soil samples inside the rings might contain traces of fires, pollen from plants grown for ceremonies, or the bones of animals offered as gifts. Below us now lies one such ring, half buried, yet still graceful. The surrounding plain stretches empty, but in its center, grass grows a little greener, nourished by soil, enriched over centuries of human activity. The stones, worn and leaning, still mark the circle's edge. You can almost imagine the murmurs of a gathering, the flicker of firelight, the scent of wood smoke on the wind. As the satellite drifts onward, the ring slips behind us, its silent conversation with the stars continuing without us. Ahead lies something slower, darker, a kind of ring painted not by hand or by life, but by time itself, one mineral grain at a time. The grasslands fall away into a stony wilderness, the colors muted, now soft browns, dusty grays, the occasional flicker of shadow where a low hill breaks the light. At first the land seems bare, but then you notice it faint dark circles staining the pale rock like ink blots that have sunk into the surface over centuries. These are not craters or crop marks or deliberate carvings. They are the work of slow chemistry and slower time rings born from desert varnish. Desert varnish is a thin, dark coating of manganese, iron, and clay minerals that forms on exposed rock in arid regions. It builds so slowly that you could measure its growth in fractions of a millimeter over 1,000 years. It is, in a way, the desert skin, polished by wind, burned by sun, and patiently painted by the elements. Here, for reasons not entirely understood, the varnish sometimes grows in rings. A central patch of rock will darken, first perhaps where a small amount of moisture collects, feeding the microbes that help deposit the minerals. Over decades or centuries, the process moves outward, forming a halo of rich, almost black pigment around a paler center. From above, these halos look like charcoal outlines drawn onto the earth. You might ask yourself, what stories could a single ring of desert varnish tell if it had the patience to speak? It has seen countless sunrises, endured storms of sand, felt the tremor of distant earthquakes, and been brushed by the footsteps of creatures long gone. Scientists studying desert varnish have found it can trap dust, pollen, and even atmospheric particles from volcanic eruptions. Some varnish layers may be tens of thousands of years old, storing environmental clues as neatly as tree rings store seasons. If Earth were a patient archivist, these rings would be her sealed envelopes, messages written in the ink of minerals left unopened for millennia. The one beneath us now is large enough to walk across in a few minutes, though its edge is so subtle you might miss it entirely at ground level. Up close, you'd see a glossy sheen, almost like a thin coat of varnish on wood. You could run your fingers across it and feel the faint smoothness, knowing each grain of mineral has been laid there by wind and rain one after another for longer than written history. From space, however, the ring is perfectly clear, its color standing out against the lighter stone. The surrounding desert stretches endlessly in all directions, but here the ground wears a quiet crown, its circle complete. No plants grow in the center, just bare rock warm in the sun and cool under the moon. As the satellite glides forward, more of these halos appear, scattered like coins left by a wandering hand. They overlap in places, forming complex patterns, rings within rings, each from a different century or millennium. And slowly, the varnish will keep growing its dark edge, advancing grain by grain, a pace so slow it almost feels like stillness. Soon the rings fade as the land changes. Once again the air below, growing warmer, the colors richer. Somewhere ahead, a hidden source of water is quietly shaping the next perfect circle we will see. The arid flats soften into a patchwork of muted greens and sandy golds, like a painter has washed the land with diluted watercolors. You can feel a shift in the air, still warm, but carrying the faintest trace of moisture. The circles here are not ink dark, like the varnished rings we left behind. These are pale, ghostly shapes that appear only when seen from above their edges, curling like the rim of an ancient teacup. These are salt rings born where water once pooled, then vanished into the thirsty sky. Imagine a shallow lake that breathes in rain during rare storms, holding the gift for a short time before the sun drinks it dry. As the water retreats, it leaves behind a fringe of minerals, sodium, magnesium, and calcium layered in a delicate crust. Over years or decades, each cycle pushes that ring outward, the white line inching across the earth like lace slowly being unrolled. You might ask yourself, what would it be like to witness that retreat in real time, to watch a ring take shape as the last puddles shimmer under the afternoon sun? Would you feel sadness at the water's vanishing, or wonder at the geometry it leaves behind? Some of these salt rings are young, just a few decades old, the afterimage of a floodplain's brief revival. Others are ancient, tracing the former shorelines of lakes that dried up thousands of years ago. In Utah's Bonneville Salt Flats, rings mark the ghost boundaries of a massive Ice Age lake, its shoreline still etched into the hills. In Bolivia's Salar de Uyuni, the largest salt flat on Earth, faint arcs ripple across the surface where water once lapped. From the satellite's view, the ring below us glistens faintly in the sunlight as though it's still wet. But it is dry, so dry that even the smallest shrubs keep their roots far from the center. Salt is a silent gatekeeper, permitting only the hardiest plants to creep near. The crust crunches underfoot like thin ice, breaking into jagged fragments that reflect the sky in tiny mirrored shards. Salt rings can also whisper to scientists about the climate. The width and layering of each band can reveal the rhythm of wet and dry years, much like tree rings record the passing of seasons. Even trapped within these brittle crystals are tiny bubbles of air, samples of an atmosphere long gone, preserved as though time itself had paused. The ring below is wide enough to hold a small town inside its boundary. From above it looks serene, its white outline crisp against the earth-toned soil. But here and there the pattern is broken by faint, meandering tracks, perhaps left by antelope camels or wild donkeys seeking water that hasn't been here for years. From space it is perfect. On the ground it is a reminder water can be both giver and taker, shaping the land even as it departs. The satellite drifts onward, leaving the shimmering circle behind, and the land begins to darken once more, as if preparing to reveal something forged, not by water or wind, but by fire. The ground below shifts in tone again, this time to a deep, rusty brown streaked with black, as if someone has painted the earth in broad, sweeping strokes of ash and ember. You can almost feel the warmth radiating upward, even though the eruptions that made these shapes may have happened centuries ago. Here the rings are not gentle traces of water or wind, they are the fire-born halos of volcanic craters. From above each crater is a dark pupil, surrounded by lighter rock, the circle forming as molten rock blasted outward, then cooled in perfect symmetry. Around some you see double or triple bands, like ripples frozen mid-spread, each ring marking a past eruption. The volcanic cones stand quietly now, their summits collapsed into bowl-like calderas. But you know, in the patient way of geology, that quiet doesn't mean finished. Imagine standing on the rim of one of these rings, the ground warm beneath your boots, the scent of sulfur faint in the air. Your mind might wander to the moment of its birth, the earth trembling, a roar rising from the depths, molten rock fountaining skyward in arcs of fire. The air would shimmer with heat, and the land itself would reshape in minutes what was once a forest or a meadow, becoming a dark, raw scar encircled by rock thrown far from the vent. Some of these craters have filled with water over the centuries, forming sapphire lakes whose surfaces gleam like coins in the sunlight. In Oregon's Crater Lake, the ring is defined not by ash, but by the sheer walls of the caldera, more than 600 meters high, in places remnants of Mount Mazama's cataclysmic collapse 7,700 years ago. Others, like the Darvaza gas crater in Turkmenistan, glow with open flame, earning it the nickname, the door to hell. That one's ring is lit from within a circle of fire that never sleeps. You might ask yourself, if the ground beneath you could erupt without warning, would you feel fear or awe? Would you run from the heat, or stay to witness the land writing its newest story? Satellites read these volcanic rings not just as landmarks, but as data. Infrared sensors detect lingering warmth, spectral imaging spots minerals newly forged in the blast, olivine feldspar magnetite, each with its own fingerprint. These clues tell scientists how long ago the eruption happened and what forces brewed beneath the surface. One crater below us is so vast that clouds drift across its diameter, their shadows tracing its inner slope. The ring is sharp, dark, and perfect, its walls still steep, as though the eruption happened just yesterday in geological time. Yet here life is creeping back. Grasses soften the lower rim. Small animals have burrowed into the volcanic soil, which, though hostile at first, will one day feed forests. From space, these fire-born rings look motionless circles that never change. But the truth is, they are always shifting, eroding, greening, and in some cases preparing to flare again. The satellite hums onward, carrying us toward another kind of ring, one painted not in fire or salt, but in ice that dances under the midnight sun. Now the window below fades to white, pure luminous, and unbroken at first glance, until your eyes begin to pick out the faint bluish arcs pressed into the ice. They are so subtle you might miss them entirely if you weren't looking for them. These are frozen rings, sculpted not by heat or water, but by an ancient choreography of ice and wind. In the high Arctic and Antarctic, the ground doesn't always stay still. Here beneath the snow permafrost, breathes slowly swelling in the summer's brief warmth, shrinking in the long cold. That rise and fall can push stones and sediment into perfect repeating arcs. When seen from above, they form pale concentric circles almost ghostly against the frozen expanse. Imagine walking across one of these icy rings. Your boots would crunch on a mosaic of frost-heaved stones, each one placed by the Earth's patient hand. The wind here speaks in a steady whisper, carrying with it a smell that's almost nothing, clean, sharp, and dry. Your breath fogs the air, a fleeting cloud that disappears into the endless white. Some of these circles are far older than any human memory. In Siberia, patterned ground like this has been forming for tens of thousands of years, each freeze-thaw cycle a brushstroke in an artwork so vast it can only be truly seen from space. In Greenland, satellite images reveal icy rings more than 30 meters across their arcs, sharp and unbroken even after centuries of snowstorms. You might wonder if the planet is warming. Will these patterns vanish? Will the rings blur and melt, their story erased in a single human lifetime? Scientists think about that too. Data from the European Space Agency's Sentinel satellites shows changes in permafrost depth year by year, the pale rings shifting as the ground softens. Some fade entirely, replaced by ponds or by darker thawed soil. Others grow more pronounced as cracks fill with drifting snow and deepen under repeated freezing. But not all frozen rings are static. In Antarctica, some form on the surface of sea ice itself, temporary halos traced by trapped air bubbles beneath the ice sheet. These can be vast, perfect circles that drift with the current only to break apart when the ice finally fractures in spring. From this high vantage point, the icy rings glint like hidden coins scattered across a frosted tabletop. You can almost imagine the polar night bending down to admire them, its long darkness stroking each arc with silver light from the moon. And just ahead, where the white gives way to shades of gold and green, we're about to see another kind of ring, entirely one so large and full of life that it's visible from space, even in the heart of the ocean. The white of the polar world falls away beneath you, replaced by a deep, endless blue. But here, floating on the ocean's surface, is a ring of a completely different nature, warm, alive, and breathing in slow motion. This is a coral atoll, a halo of life so large it can only be fully appreciated from above. From up here, it looks like a painter has taken a single brushstroke of turquoise and wrapped it in a perfect loop across the sea. Inside the ring, the water is pale and calm, a sheltered lagoon. Outside, the ocean darkens almost instantly, the depth dropping away into cobalt shadows. If you could drift down now and stand ankle-deep on the atoll's rim, the coral beneath your feet would feel like hardened lace, every curve the fossilized skeleton of something that was once alive. These reefs are living fortresses, built grain by grain over thousands of years by tiny creatures. Coral polyps, each one smaller than a grain of rice, yet together shaping structures large enough to be seen from space. You might ask yourself, how can something so delicate survive the constant push of waves, storms, and time? The answer is in the rhythm of the reef's life. As each coral polyp dies, its skeleton remains, giving the next generation a place to anchor. Layer after layer, century after century, the atoll grows upward and outward until it forms a protective ring. Some atolls, like Kwajalein in the Marshall Islands, stretch more than 100 kilometers across their lagoon, big enough to hold an entire city. Others, tucked away in the Maldives or the Tuamotu archipelago, form nearly perfect circles, so striking they look almost artificial when seen from a satellite. The colors here are impossible to ignore. The reef itself is a mosaic of crimson violet, emerald, and gold, and the water shifts from the palest jade in the lagoon to deep sapphire beyond the rim. The sun refracts into shimmering patterns on the seabed, making it look as if the ocean is breathing light. Coral atolls also keep secrets. Beneath their beauty, they store a history of the sea. Itself, tiny chemical traces in their limestone skeletons that tell scientists about centuries of ocean temperatures, currents, and even ancient El Niño events. By drilling narrow cores through the atoll's rings, researchers can read this watery archive year by year, like tree rings written in salt and stone. Yet these rings are fragile. Rising sea levels and warming waters can bleach the coral, stripping it of color and life. Some atolls have begun to sink, not because their structure is collapsing, but because the sea is rising faster than the coral can grow. Others are shifting, reshaped by stronger storms. Still, in many places, reefs are adapting their polyps, finding new ways to survive in warmer, more acidic seas. From space, these coral rings shine brightest at midday when the sun is high and the ocean's surface becomes a mirror. They glimmer like jewelry scattered on the dark velvet of the deep. You can almost imagine the Earth wearing them, each atoll a reminder of its wild creativity. Ahead, another kind of ocean ring waits, not built by living creatures, but by the currents themselves, spiraling vast whirlpools that roam the open seas, unseen by the human eye, until a satellite captures their perfect shape. Far out in the open ocean, where there is no land in sight for hundreds of kilometers, the water itself begins to gather into a slow, patient dance. From space, this dance appears as a ring, an enormous spiraling whirlpool called an ocean gyre or an eddy. Unlike the sharp blue outlines of coral atolls, these rings are more like ghostly fingerprints pressed onto the surface of the sea. You drift above one, now watching, as the deep blue turns slightly greener in the center, a sign of nutrients pulled upward from the depths. It's a circle without walls, without a visible border. Yet its edge is real. Scientists can map it by measuring the subtle curves of the water's surface, sometimes only a few centimeters high, held there by the pull of the Earth's rotation. The ocean is always moving, and these rings are its slow-motion knots. They can be huge, some stretching over 300 kilometers, across large enough to swallow entire countries, and they can last for months, even years, slowly wandering across the sea. If you could drop a leaf into the water at their edge, it might take weeks to make a single lap around the ring before being released. You might wonder what could possibly form something so vast and yet so invisible to anyone standing on a ship's deck. The answer lies in the meeting of water masses, where warm and cold currents brush past each other. The difference in temperature and density sets the water spinning, creating a self-contained loop that traps everything inside it. Sometimes these rings are like floating gardens. Warm core eddies trap tropical water and drift into cooler regions, carrying fish plankton and even drifting seeds from faraway shores. Cold core eddies do the opposite, pulling nutrient-rich deep water to the surface, triggering blooms of phytoplankton so large they can be seen from orbit as swirling green spirals. These blooms feed everything from tiny krill to great whales, all inside the invisible embrace of the ring. But not all is idyllic. Some gyres, especially the permanent ones, like the North Pacific Gyre, collect more than life, they collect our waste. In the calm center of the gyre, floating debris gathers over years into drifting rafts of plastic, forming what's often called a garbage patch. From above, it's not a solid island, but a haze of particles that move and shift with the water, a reminder that these rings are both life-givers and collectors of our mistakes. From your high perch, you can see sunlight catching the subtle curves of the gyre's surface, bending light into ripples of silver. It's as if the ocean is wearing a slow-turning crown. The satellites that capture these shapes don't look for color. They look for patterns in sea height, temperature, and chlorophyll, translating invisible forces into visible rings. The most mesmerizing thing about them is their patience. While waves crash and tides rise and fall with daily rhythms, these gyres and eddies turn like clock hands on a calendar, far slower than our own reminders that the ocean's heartbeat is vast, unhurried, and steady. Ahead, the ocean gives way to the land again, but this time the rings you see are not in the sea or the sky. They are burned into the earth itself, scars from moments of unimaginable force. These are the craters. From above, they look like giant coins pressed into the earth, perfect or near-perfect circles that ripple outward into the landscape. You are gazing at impact craters, the lasting signatures of moments when something from space met the earth with a force beyond anything we can imagine in our daily lives. Some are small, just a few hundred meters across, hidden in forests or deserts, like forgotten ponds drained of water. Others are so vast you can barely see their edges from orbit, such as the Vredefort crater in South Africa, which spans more than 300 kilometers, the scar from a collision over 2 billion years ago. Its age and erosion mean that much of its form is softened, but its ring structure is still there, a whisper of the unimaginable event that made it. Picture it a rock or chunk of metal, perhaps only a few kilometers wide, traveling faster than a bullet entering the atmosphere. In a few short seconds, the air before it compresses and heats, turning the object into a blazing fireball. And then impact. The ground beneath doesn't just break, it flows like liquid for a moment, rippling outward. The force digs deep, creating a central pit, then rebounds upward, forming a raised peak in the middle of the new crater. The ground around collapses into terraces, forming a ring or series of rings. From space, those rings are like ripples on a frozen pond preserved for millennia. Even when vegetation covers them, radar and satellite imaging reveal their geometry. They remind us that Earth is not isolated, that it moves through a cosmic shooting gallery, where impacts, though rare in human timescales, are inevitable over geological ages. Some craters hide their rings beneath water. Lake Manicouagan in Canada is one of the most beautiful examples, a ring-shaped lake nearly 100 kilometers across, encircling a forested island. It looks serene from above, but it's the mark of a 200-million-year-old collision that would have devastated the surrounding world. Others are shrouded in sand or ice. In Antarctica, beneath kilometers of ice, sheet scientists suspect there may be ancient craters, frozen and preserved from a time before the continent was cloaked in white. What stories might they tell if we could see them? You might ask yourself, if such impacts have happened before, could they happen again? The answer is yes, and in fact, tiny impacts happen every day as meteorites pepper the atmosphere. Most burn up harmlessly, leaving nothing but shooting stars. But once in a very long while, something big enough to leave a ring-shaped wound arrives. Standing well floating above these ancient scars, you feel an odd mix of awe and humility. The craters are reminders of destruction, yes, but also of resilience. Life returned to them, rivers carved through them, forests grew inside them, even cities have been built on their rims. Earth has a way of turning even the deepest scars into part of its living skin. And just as impacts carve rings into the crust, the planet has its own slow internal forces that can create vast circular formations without anything from space ever touching it. Ahead lies one of the strangest of these, a place where the Earth's own geology has drawn a perfect target on its surface. You drift now toward the Sahara, where the sand stretches out in endless wind-shaped dunes, the color shifting from pale gold to deep amber under the moving sun. At first you think you're just seeing another part of the desert until a faint circle begins to emerge beneath you. Then another, and another. Layer upon layer of curved ridges spiral outward like the growth rings of a colossal tree. This is the riche structure often called the Eye of the Sahara. From the ground, it's almost impossible to grasp its shape, just ridges of rock and valleys winding away into the distance. But from above it becomes an almost perfect bullseye, 40 kilometers wide. A giant eye staring up from the desert, surrounded by ripples of sand. It wasn't made by a meteor. That's the first surprise. When it was discovered by astronauts and photographed from space, many thought it must be an impact crater. But scientists now believe it's the eroded remains of a huge dome of rock pushed up by forces deep in the Earth's crust. Over millions of years, wind and water patiently carved away the layers, leaving behind concentric rings like a geologic fingerprint. The oldest rocks here are more than 600 million years old. Imagine the stories they could tell ancient oceans lapping over this place. Strange early life forms swimming where now only sand blows. Later the land rose folded and cracked, then slowly yielded to the elements until it formed this perfect target-like form. There's something hypnotic about the eye. It draws you in not just visually, but in the way it sparks questions. Why here? Why so perfectly shaped? Could other such formations be hiding under forests or oceans waiting to be revealed? From space, the eye's colors shift tan and rust bands pale gray limestone, deeper blue-black basalt. It's as if the earth painted an iris around its own pupil. And if you let your mind wander, you might imagine the Sahara blinking slowly over the age's sand dunes, like eyelashes moving in the wind. The Eye of the Sahara is also a reminder that not all rings are scars. Some are simply the product of patience and time, of forces that push, and others that pull, of elements working together without a moment of violence. You feel a kind of calm here, even as the desert heat radiates upward. Ahead, more subtle rings are waiting circles that aren't carved in stone or sand, but in the living patterns of our oceans. They form, shift, and vanish like breath, and yet they can be seen from hundreds of kilometers above. Now the desert fades beneath you, replaced by the deep, endless blue of the Atlantic Ocean. From here, far above the surface, seems smooth, just a single shimmering plain. But as your gaze lingers, you notice faint, lighter circles swirling across the water. They're not drawn in chalk or paint, but in moving currents themselves. These are oceanic eddies, vast spinning rings of water that can be hundreds of kilometers across. They're born from the meeting of different currents, like the Gulf Stream colliding with colder waters, and once they start spinning, they can last for months, sometimes even years, holding their circular shape as if by some quiet magic. In person, you would never see them. From a boat's deck, the sea just looks like water rolling endlessly on. But from space satellites equipped with sensors that can detect subtle temperature differences or slight changes in the ocean's height, can trace their shape. Each one is a living, moving ring, spiraling slowly like a massive underwater galaxy. Some of these eddies carry warm water into colder regions, nurturing bursts of plankton blooms, the base of the marine food chain. Others spin the opposite way, pulling nutrients from deep below to the surface. This invisible stirring sustains life on a scale you can barely imagine, feeding fish whales and entire ecosystems. Think about it: if the ocean is the planet's circulatory system, these eddies are like the slow looping pulses that keep nutrients and energy flowing. Without them, the seas would be poorer, quieter, perhaps even lifeless in places where now they thrive. They're beautiful in their own way, too. From above, a warm water eddy might glow faintly red, in a satellite's false color image, a cool water one, a shade of cobalt blue. Together they dot the oceans like ghostly fingerprints, proof of the ceaseless movement beneath the calm surface. And they invite questions. If you could drift on one for months, where would you end up? Could you ride the circular current, like a slow, spiraling elevator from one ocean region to another? Would it feel endless or oddly comforting to spin gently across the sea? Even the ocean itself seems to enjoy the repetition, drawing ring after ring in water, letting them form and fade, like thoughts passing through a dreaming mind. And as you hover above, watching the subtle spirals widen and dissolve, you feel a quiet connection. These circles are the heartbeat of something vast, something alive. Ahead now lies the final set of rings, a place where the lines are sharper, more perfect, and more deliberate than almost anything else you've seen. They are not accidents of erosion or swirling water, but markers, messages etched into the surface of the Earth. The view sharpens as the satellite glides into position, revealing a flat, dry expanse somewhere in the high desert of Peru. At first glance, it seems unremarkable, just miles of pale earth stretching toward the horizon. Then your eyes begin to pick out lines, long straight lines, circles, spirals. Shapes so vast they can only be fully seen from up here, hundreds of meters above the ground. These are the Nazca lines, one of Earth's most enduring mysteries. Etched into the desert's surface by removing the top layer of dark, oxidized pebbles to reveal the lighter soil beneath, they have survived for more than 1,000 years, untouched by rain or wind. Many are simple geometric forms, including perfect rings, circles that sit in quiet symmetry with nothing else around them. Others are animals, plants, and abstract shapes. But it's the circles, the pure, unbroken loops, that feel most timeless. From here, each ring looks flawless. Some are huge, more than 100 meters across, while others are smaller, tucked between lines like notes on a sheet of music. Why were they made? Some theories suggest they were ceremonial paths, meant to be walked in ritual silence. Others imagine they were giant astronomical markers, tracking the movement of the sun, moon, or stars. If you stood in one on the ground, it would just be a low groove, maybe ankle deep, the horizon stretching out blankly around you. The perfection of its curve would be invisible without flight. Only from above does the intent reveal itself. That's part of the magic, the idea that whoever made these rings was creating for an audience they could never join, perhaps one far above. You might ask yourself, were these meant for the gods, for ancestors, or perhaps for no one at all, a meditative act of making circles for the sheer joy of geometry on an infinite canvas of desert? Scientists study the alignment of the shapes, the pigments of the soil, the dates of their creation. They find patterns, but never enough to pin down a single explanation. And maybe that's the point. Not all rings want to be solved. Some are content to remain questions, their answers curling quietly in on themselves like the circles they form. As the last of these ancient lines slides past beneath you, the Earth's rings, natural and human-made, begin to merge in your mind. Waves, forests, stones, ice clouds, crops and deserts, all drawing their own loops, whether by accident or intention, in the endless conversation between land life and time. And so the journey comes to rest here, above a circle that has outlived its makers, still perfect in its silence, still waiting for whoever will look down and see it next. And now, as we drift higher, still the lines and rings begin to blur, fading into a single soft memory of shapes and patterns. You've traced them across oceans, deserts, forests, ice, and stone, each one whispering its own quiet story. The world below is slowing, or maybe it's just you. Your breathing evens out. The steady rhythm of your heartbeat feels like its own circle looping back again and again, reassuring you that you're still here, still safe, still part of this planet's quiet patterns. Up here, the air is so still, you can almost hear it, like the hush before sleep, when the day finally loosens its hold. The colors below are dimming into muted blues and grays, edges, softening details melting away. Soon, there will be only darkness, but not an empty darkness, one that feels warm, protective, like a blanket pulled gently over your shoulders. The rings we've seen tonight will keep spinning, glowing, growing, and fading without you watching. And that's all right. You can let them go for now, knowing they'll be here when you're ready to find them again. If you've enjoyed this journey, I'd be quietly grateful if you'd give this video a like or tap that subscribe button for more peaceful explorations with the Sleepy Scientist. It helps more than you might imagine. And before you drift off, I'd still love to know, where in the world are you listening? From what time it is there? Leave a comment if you're feeling cozy enough to share. It's always a quiet joy to see this sleepy little community ripple across time zones and continents. Good night. Sweet dreams.